Okay, so that right triangle, do you remember that right triangle? I want you to take a moment to think about it. If I make an XY plane, I know that if I make a point over here in quadrant 1, it has an x comma y coordinate. I know that if I instead look at that point as a polar point, it is r comma theta. If you can create that triangle, then conjure up your SOHCAHTOA. So everybody, conjure up that SOHCAHTOA. Also, I realized in period 1 that I may want to do a unit circle video. Some of you may want a refresher on that. All right, so you guys know that sine is what over what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, opposite over adjacent. What you want to take from this is what is y equal to and what is x equal to. You need to know those quickly. So y is equal to r sine theta, x is equal to r cosine theta. And then also Pythagorean theorem. These are the only formulas they say that you should know. However, there are more formulas you can create from this triangle. So if you are asked to, not there. Okay, I lost my place. Here we go. If you are asked to convert a polar to a Cartesian, primarily this bunch right here, I have found that the easiest way to do that is to literally, for each trig function you see, pull that triangle out. So, for example, let's say we were doing number 19 here. So go to that triangle and figure out what is cosecant theta. And so you've got to remember, actually, what is cosecant's reciprocal? And, oh, I can't see your chat. What is your reciprocal of cosecant? Okay, there we go. Oh, and of course, guess who? It's always a sophomore. Okay, so you want to remember cosecant is 1 over sine. You know that sine is opposite over hypotenuse. So that means for cosecant, you're doing hypotenuse over opposite. So cosecant is r divided by y. If you replace that trig function, if you replace every trig function that is there, and then just play with the algebra until you no longer have x's or y's, take a look at what that is. This would be a multiple choice problem, by the way. And if your algebra is a little rusty, multiply by that denominator and you'll see it. So in a multiple choice setting, it might be that there are 5 different equations and you have to find the right one that this matches. Or maybe it gives you 5 different graphs and you have to figure out which graph it is. Now, if it is a standard type of curve that you would be expected to know, then it might be one of these and you should be able to quickly figure out which graph it is based on being familiar with these. But it also can be that you might be able to convert the equation itself and then think about what does that Cartesian equation look like. So you've got 2 things you're able to do. And this then, if it was a graphing choice, I'm drawing a very quick graph, you would see that only one of them draws that. And then that would be your graph if that were the multiple choice option. So be able to convert in that way. And I want to say that if, just in case, if you had, say, just a theta by itself, there's an expectation of what you're going to use. Any good guesses? They're going to expect you to use this. So if the tangent of theta is y over x, where theta is the input and y over x is the output, then when you swap it so that theta is the output, y over x is the input. And what function is that for? Inverse tangent. So if you happen to have a lone theta, throw in their inverse tangent of y over x. But otherwise, your thetas should be in trig functions, and once you get that set up, you can just play with the algebra until something works out. So that's one thing. Another thing is you need to be able to find slope. So let's look at number 59 here. Keep in mind that r is a function with respect to theta. But if you're going to find slope anytime with polar, everyone's paying attention right now. Oh, Taya says hi. Hi, Taya. Jackie says hi. Okay. Everyone's paying attention. You need to convert to a parametric format. How do you convert to a parametric format? Whoop, 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 whoop. Those 2. But what you really want to use, oh, I've already got it there. I did this problem earlier with period 1. So how about I just go over here. Okay, so you want to use y equals r sine theta and x equals r cosine theta. R is the function itself, and that function was 1 over theta. You can see that right here. So if you need to find dy dx, you are first going to take what x is equal to and what y is equal to and convert. So again, the function that we were being asked to find a slope for was r equals 1 over theta. This is coming directly from a formula that you know to begin with. Once you do that, you're going to have y and x both in terms of theta. And once that happens, then when you do dy dx, you just need to do dy d theta over dx d theta. And with this situation, you can choose to use the quotient rule or the product rule, but you've got to go for it. So everybody, let's do that derivative. Find dy d theta, divide it by dx d theta, where this is your y and your x. And by the way, I will tell you that I have learned to write the y first. You know how usually you go x equals and then y equals? I can't tell you how many times I accidentally wrote the reciprocal of the slope because I just kind of went with the first thing I see. It's easy to do, so my recommendation is write the y down first in that parametric format. Okay, so quotient rule, we get loaded on math with an A. And do you want me to just go to what it looks like? Since I already did it. So you've got, for the dy d theta, low d high minus high d low, square the bottom, away we go. And then the x, low d high minus high d low, square the bottom, away we go. The lovely thing is those divided by theta squareds are gone. And then we simplify over to here. Now, the theta that we were asked to find the slope at was theta equals pi. So if you don't know your unit circle, or if you get clumsy with your unit circle, draw sine and cosine. You know how to graph sine and cosine. And then look at where are they located when you are at pi. Sine of pi is 0, cosine of pi is -1. And then just throw all that in, and out pops the slope. So hopefully this doesn't seem too bad. It's just a matter of following the formulas. Now, next question is, do you remember the area formula that we need to use? And in period 1, a lot of people went, oh no, totally forgot. So, reminder, area of a sector. You know area of a circle is pi r squared. And when you're dealing with a theta amount out of a full amount of 2 pi, that quickly simplifies to 1/2 r squared theta. Theta is cut up into tiny little pieces, so that becomes the d theta. So really, you're just remembering 1/2 r squared. That is the key, 1/2 r squared. And now we're going to do some area finding. I'm sorry. I hope none of you have issues with blinking lights. Come on, computer, don't be such a pain. Okay. Let's see, I'm trying to find, if I do something that I did before break, you don't remember it anyway. So let's do 27 together. R equals 3 cosine theta and R equals 1 plus cosine theta. We're going to first graph together just to get that better feel of graphing. And I'm going to do more with it than what the problem is asking. Whoops, microphone dropping. Come on, chair, move forward. There we go. So this particular problem in your textbook is asking you to find the area of the region that lies inside the first curve but outside the second curve. I'm going to do that, and I'm going to do inside both. And I will tell you that actually the AP test typically does inside both. So 3 cosine theta, I'm going to start with that. No, stop being that way. What was the other R? Thank you. Okay, so I'm going to start with this one. And if I had to graph it and I couldn't remember exactly how it went, I would first look at the Cartesian graph. Cosine goes, I don't know if that noise helped, but it is just theta, so it's only going out to 2 pi when it does one cycle. With the multiplication by 3, that stretches it. Now, what is that going to graph on a polar grid? So you can see that from 0 to pi over 2, it's going from an R value of 3, and it is spiraling into the pole to an R value of 0. If you want, you can go backward and see that from negative pi over 2 to 0, it started at 0 and spiraled out to that 3 value. Moving forward, if I go from pi over 2 to 3 pi over 2, I have a negative radius. So a negative radius will, instead of graphing along here, it will graph, wait a minute, didn't we just draw that? Ha ha ha, ha ha ha. Yes, yes we did. So that negative radius is just going to redraw over what we already have. Yeah.
This may be a dumb question, but how do you know it's not like an eye shape?
So, yeah. The main reason that we know that is by converting. If I take R equals 3 cosine theta and I convert it into Cartesian, I would start with cosine theta is equal to, and then on that triangle, what is that equal to? And then keep playing with it, multiply both sides by R. And then R squared is Pythagorean theorem. Now at this point, you want to recognize that this will create a circle. You would have to go through a completing the square process, but just that's far enough for you to know that that does have to be a circle. And this is also why it's good to be familiar with those common graphs. With the common graphs, if you've been playing with them for a few weeks instead of just the amount of time we're doing, you get to where you just know it when you see it after you've graphed it too many times. So familiarizing yourself with this helps, which is what I'm partly trying to do as I review with you. Down here? Yeah. Okay, now I'm going to grab the other one and we're going to take a look at its graph. So if I were to graph the Cartesian graph of 1 plus cosine theta, that's just going to take our cosine that we know happens, shift it up 1 unit. So the center that was 0 is now 1. The highest point was 1, now it's 2. The lowest point was negative 1, now it's 0. Then do your basic cosine graph, which starts at I need like one of those noisemaker things. Yes, thank you, slide whistle. I need one of those. And you know that it does this out to 2 pi. And do you see that this is telling you cardioid? It touches the x-axis at one place, and you can see where that cusp occurs while you're at it. That cusp is occurring at pi itself. Now, we have points we can plot. When my angle is 0, my radius is 2. Then when my angle hits pi over 2, I have spiraled in to 1. Then I continue spiraling into 0. And then I duplicate. You have to be able to figure out where they intersect. When you draw them, you can get a good picture of where you're looking for, but also, how do you figure out where things intersect? You set them equal. We want to know when their r's are equal to each other. So 3 cosine theta equals 1 plus cosine theta. Subtract a cosine theta, divide by 2. And now you want to know that unit circle. So with the unit circle, cosine represents x. Because it's a unit circle, this is 1 and negative 1. And then the special numbers are 1 over 2, root 2 over 2, root 3 over 2, and negative 1 over 2, negative root 2 over 2, negative root 3 over 2, and then there's 0 in the middle. Positive 1/2 is the first special x coordinate to the right of the origin. That takes me to the angles pi over 3 and 5 pi over 3. You will not have a unit circle on the AP exam. And so being able to get that they intersect when the cosine of theta is 1/2 allows you to be very clear about what angle this is. However, if you are doing area, make sure that you realize this is negative pi over 3. Because if you create your integral by going from this angle and sweeping here, it has to be negative pi over 3 to positive pi over 3. If you do 5 pi over 3 to pi over 3, it will send you backward and give you the opposite of what you're looking for. So the problem was inside the blue circle, but outside the green cardioid. So that means this region is what we're trying to find the area of. The area formula is 1/2 r squared. And you're going to have to look at first integrating the one that is furthest away, and that's going to give you all this area. Draw spokes coming out of the origin to see what region you're actually doing an area of. So if I do negative pi over 3 to positive pi over 3, and I integrate the blue curve, which was 3 cosine theta, then that's more area than what we actually wanted. Now, I'm going to use the very same angle range to subtract away all of these. And notice I'm drawing spokes. If I integrate through that same angle region, then I can just go, hey, 1/2 r squared d theta. And that time that r is 1 plus cosine theta. So more than likely, if this is multiple choice, you are going to have an integral, and you've got to figure out which one it is. One of the issues is symmetry. You want to notice that both of these are symmetric over the x-axis. So if you went and said, I'm going to double this, I'll do great. If I say times 2, I can then instead start at 0. And then you're not going to see any number multiplied out front. And you're going to get area problems every day this week to play with. Do you know that you may have to simplify from here? The only trig identity that you want to make sure you know, I'm going to start it and I'll see if you know how the rest goes. Sine squared plus. So this identity might need to be used. It may not need to be used, but be ready with it. Because they're going to have this integrand simplified however they decide to simplify it in their multiple choice answers. Yeah.
On the test, will you give us the graph when you're defining area?
Yeah. Yeah, I will give you the graphs on the test. And with the graphs given, you can pretty much tell what the intersection is. So that takes that aspect out of it. Usually the AP test will give you the graph, but when we do prep for that AP test, the more familiar you are with creating the graph, you can deal with whatever they throw your way. But often they do give the graph. Okay. You are not going to do any integration this week. You're not integrating these at all. If you are, you're integrating them on calculator because we have more than a month after the AP exam. After the AP exam, we're going to cover second semester topics that aren't on the AP exam. That includes some additional advanced integration techniques that you would need to solve these. So you will not be expected to solve these types of integrals on the AP exam. Yeah. After the AP test, I'm just going to give another test on the things that we're covering post-AP test. Everything prior to AP test will be gone unless we re-go over it. Yeah. The good news. I want to make sure for that month after the AP test that you're prepared for the next calculus course. And the most important thing to prep you for the next calculus course is to make sure you feel stronger with polar, stronger with parametric, very unit circle savvy, and those advanced integration techniques. That's really about it. You're not going to see infinite series in the next calculus course. However, if you're going to a quarter system, you will be redoing series again. It overlaps. But if you choose to do a third semester of calculus through a local college, that will save you having to deal with the overlap on the quarter system. So just be aware of that. That is actually a big deal. Question?
What is the practice AP test that we do
A test grade. It will be curved like an AP. Yeah. So basically, getting about 2/3 correct is a 5, and that's like an A+. If you can keep your head above the water with 50%, you're pretty safe. So it may seem easy on the offset, but we have a lot of studying to do. And a good chunk of the BC exam is infinite series. But I'm going to go through a whole review of AB stuff, and I'm going to have to make some recordings and things. Question?
How like the BC exam has like part that's going to be counted towards the AB subject?
It's over half, but how much over, I'm not entirely sure if I've run across that. It's a little bit over half. 3 of your free response problems will be the same free response problems that the AB test has. Mm-hmm. And also, you get credit for first and second semester calculus if you pass that BC exam. If you don't pass the BC exam but pass the AB subscore, you get just first semester credit. But passing that BC, just the whole thing. Which allows you to move on to the multivariable calculus, which is basically going to take your first semester calculus and pop it out a dimension. And the best way to prepare for that is to play with 3D graphics, creating and drawing things in 3-dimensional realms. There are lots of programs, free programs out there that will draw in 3 dimensions. That is honestly the biggest issue I've seen with people, is being able to visualize the 3 dimensions and kind of rotate it in your head. If you've played with things on a 2D computer screen that are 3-dimensional in nature and you've turned them around, your head is ready to see that. But if you haven't done that, not everyone can just have it in their head. And a fair warning, it's tedious at times. And by tedious, I mean like a problem takes you an entire piece of paper. One problem with a lot of algebra in between. So anyway, we have a little bit of time left. And at this point, I did not go over with you area inside both, which is typically what is more on the AP exam. So, are we paying attention? I'm going to redraw these problems. If I can. Come on. So now I'm trying to remember. It was blue circle goes out to 3. And then the green cardioid goes out to 2 here. And then we have our angle of intersection. And I'm going to focus on the top part of this. So starting from angle 0, if I'm going to be inside both, then I want to integrate the function who is closest to the pole at any angle. As I go from 0 to pi over 3, the cardioid is closest to the pole. But after pi over 3, the circle is closer to the pole. So you have to set up 2 integrals. And it's also important to understand that this blue circle does get sucked into the pole at pi over 2. Now, because I'm using symmetry, I've technically got 2 times 1/2 in front of both of these. I'm following the green cardioid from 0 to pi over 3, and that cardioid was 1 plus cosine? And then the blue circle needs to be followed, and that was 3 cosine theta. And it doesn't, you will not see it written in a multiple choice answer, but just to emphasize, it's 1/2 times that, but we are doubling. So you just won't see them. We're doubling because it's technically all of this as well. All right, so you have homework today. And if you're not able to get it online through my AP, I did put in this as a PDF file as well. And hopefully you know the calculator symbol means you can use a calculator. But understand, you don't want to use polar mode on your calculator with the AP exam. It's not helpful at all. Don't go into it. You don't even want to use parametric mode. Everything you do while you're solving things with your calculator is really just solving equations, and which you can't do in those other modes. You're going to need to solve equations and solve definite integrals. And when you solve those definite integrals, you have to write out the whole integral in the first place. So we are going to review all week. Let me stop the recording.